Hello, how are you?
Hi, good, thanks. How are you?
Good. Is the volume okay? Can you hear me okay?
Yeah, I can hear you okay. Can you hear me?
Yeah, yeah.
All right, great. All right, so we are going to have our algorithm and data structure interview session. It's going to last for 45 minutes. So, so before we start, could you please tell me about your experience and about your goals?
Sure. So right now I'm in school. I'm a master's student and doing a master's in environmental science and microbiology. I have an undergrad in computer science, and decided to do a little bit of research. And so like my career plans, my goal plans is to get a job as a programmer in tech. And yeah, I've been studying, preparing myself, brushing up on the data structures, algorithms, and have an interview with Google coming up and next week. So doing the best I can to prepare.
Got it. Okay, sounds good. All right, so we will start with me asking you like a real interview question that I usually ask in a real interview, and then we will see how it goes. Uh, yeah, so
Cool. Thank
yeah.
you.
All right, let's do. Yeah, let's start with this one.
Uh, okay, so given an integer array nums and two integers left and right, return the number of contiguous non-empty subarrays such that the value of the maximum array element in that subarray is in the range left, right. Okay, so for our first example, we have the numbers. We have the array 2, 1, 4, 3, and left equals 2, right equals 3. Um, and the result is 3 because there are three subarrays that meet the requirements: 2, 2, 1, and 3. Okay, so going to read this again just to make sure that I understand what the question is asking. So we have the array, and so two integers left and right. And we want to return the number of contiguous non-empty subarrays such that the value of the maximum array element in that subarray is in the range left, right. So because we have left 2 and right equals 3, um, so basically we want to select, so in the example here, in the given example, we want to select the subarray such that the maximum array element is between 2 and 3.
Yeah, so basically out of all those subarrays that we can have, like for
Mm-hmm.
example, 2, 2, 1, 2, 1, 4, 2, 1, 4, 3, then 1, just 1, then 1, 4, etc. until we get only 3. So for all each of these subarrays, we have to calculate what is the maximum element here. For example, for this subarray is 2, and we can
Mm-hmm.
check that is this maximum element is between this left and right. If it is the case, then it means that it meets the requirements, and we're
Mm-hmm.
going to increase some like count of these arrays. And so there are like 3 such subarrays out of all the subarrays that we can get from this input. There are 3 subarrays that meet the requirements. So one
Mm-hmm.
is 2, another one is 2, 1, and the last one is 3.
Okay, cool. Um, okay, I think I understand. So um, let's see what are the constraints of this. So what are the possible So I'm assuming left is the lower bound and right is the upper bound. Would we ever have a case where left is greater than or equal to right?
No, you can assume that is not such case.
So the left value is always lower, right?
Great. Mm-hmm.
Okay. What are the okay? So what size is the number array? Around what size is it like? I mean, does the size doesn't matter? I guess it could be large, right?
Yeah.
Okay. Um, what kind of values do we have in the array? Do we have positive numbers? We have negative numbers?
Yeah,
Have
I
any?
mean, we may have, but we can assume that we only have positive actually. Let's just assume that we only have positive numbers.
Okay, so only positive numbers for now. Okay. Um, so one thing, something that I was thinking about is that maybe something that we can do is we could like maybe go through each element in the array one by one, starting at the first element, the index position 0, and then basically what we can do is um, for each element, right? We consider as we go from left to right, uh, we consider all the possible contiguous subarrays that end at that index, and then maybe that could help somehow. So, so for example, let's say we start at 2, right? So let's start at 2, and the very first, the starting at index 0, we only have a single element that could be formed, which is 2, right? And then we check if we get the max element, which is 2, and we notice that 2 is in the range, right? Because between 2 and 3, right? So that counts. Um,
Mm-hmm.
okay, so we have 2, and then as we move to the right, we grow the array by 1, right? Then we have 2, 1,
Mm-hmm.
and then the maximum element here is um, still 2. So 2, 1 also.
Mm-hmm.
Hmm. One thing that's also like I noticed is that basically if as soon as um, as soon as we find an element that contains a valid value that's within the range, basically you can expand. Um, well, that's not true. The thing that I was gonna say is that that you could expand the element once you find any element that matches the range. I was gonna say, oh, well, you can just expand it, right? And but that's not true because as you expand it, you might hit another element that's greater than the max element, and that could be out of the range. Um, okay, so uh, brute force, I guess brute force would be brute force away would be like consider every possible subarray, right? So you could do and every possible subarray and check the elements. Um, hmm. So for brute force, what we could do is um, have like a double for loop, and inside the for loop, we could iterate through the selected subarray and then find the maximum element of each. Um,
Mm-hmm. Okay. And what would be like a time complexity of this approach?
Time complexity would be well, depending on how you, at the very least, it would be n squared, right? Because you need to have like a subarray, and then once if like you have it like a um, let's say if you have to build the array every time, every if forming every subarray, yeah, that would also add to the complexity. Um, I was thinking, like, could we, can we start with the brute force? And I feel that once we do the brute force approach, maybe I could like shorten that, find a workaround.
Okay.
Uh,
Yeah, I think it sounds like a good idea. Yeah, we can start with the brute force.
okay. So, all right. So I'm gonna have my function int uh, int get subarrays, and I'm gonna get a and I'm sorry. Is it okay if I do this in Java?
Yeah, yeah.
Sorry. And left and right. All right. So I have my function signature. Okay. And um, what I was thinking is we have two pointers. So um, let's start. So for in uh, start index equals 0. Start index less than none. Start one. Start index plus right. And then for int end index equals 0 and index less than none start length and index plus plus. So we have a double for loop, and then inside, what we can do is um, uh, subarray index equals start index, subarray index less than equal, and index array index plus plus. Okay. We could do int maximum element equals get max value nums, or actually this could be we could move that to a different function, so max element
Okay.
get max element once start items um, and then so once we have the maximum element, we check if the max element is within the range. So if max element uh, greater than equal left and max element less than or equal right? And then we could have a count. So non-good arrays, non-good subarrays. So it's non-good subarrays. And so once we exit this, we consider every possible subarray, and what we can do at the end is return non-good subarray. Okay, so how can we make this better? Okay.
Yeah. So before we going to make it better, what is the time complexity of this approach?
So yeah, so this is so double for loop n square, and this is n, right? So that would be, I think that's even like works on n squared, that's n cubed.
Mm-hmm.
So yeah.
Yeah. Also, so one more thing is that so here, are you sure you have to that you need to start from 0 here? What can be the problem?
Sorry, which line? I'm sorry.
Line 34. We start
Line.
from 0. Are you sure that it is correct?
Uh, oh, I'm sorry. Yeah, that is a typo. So we should start. Thank you. We should start with the start index.
Mm-hmm. Okay. Yeah. Now it looks good. Now we can try to make it better.
So how can we make this better? So let's go back to our problem. So we want the maximum element. So so let's say when we consider every possible subarray, we need to find a way to get the maximum and minimum element, right, in faster time. So maybe we can find a way to get it in constant time. Maybe we could have some kind of make use of a auxiliary array to keep track of the maximum values that we see so far, right?
Okay.
Um, so let's see here. So we have two. Oh, I almost hit the back button by mistake. Oops. Okay, so we have 2, 1, 4, 3. So basically, what we want to do is every time we consider this, we consider a subarray. Let's say we're here, right? All right. So what if we have something like this, where at every point we get the maximum array observed so far? So when we're at 2, the maximum element is 2. When we're at 1, the maximum element is still 2. When we're at 4, the maximum element is 4. And when we're at 3, the maximum element is still 4. Right? What if? Okay, so what if we go from the right? So if we go from the right, maybe this will lead to something. If we lead to the right, then the maximum element is 3, and this is 4 when we're here.
Mm-hmm.
This is 4, and this is 4. So this is this top element here is the maximum elements of cert going from the right. This one is going uh, from the left, and this is from the right. Does this help us? So so let's say if just considering, let's say if we consider any subarray, right? The subarray, the ends here, the maximum element would be 4. Maximum element here, 2, 1. Um, yeah, I don't see how this helps. Let's see. Um,
Yeah, I don't think like this particular thing helps much because, for example, we can also have situation when our input is something like that: 1, 2, 4, 1, 2, 3, 4, and 3.
mhm,
Okay, and then you will end up with having lots of 4s here. Like you will be having 4, 4, 4, and 4 here for the max from the maximum from the left, and the same thing will be from the maximum from the right. So basically, there's no way for you to count what is the number of subarrays that meet requirements is within this gap between these two fours, right?
mhm.
Yeah, so it's probably is there any other way we can do this with keeping track of the maximum element? Is there any other like way?
So yeah, so it's let's say if we go as we go to the array, as we let's say if we go from left to right, um, we could um, we could keep track of maybe like um, use a data structure, maybe like a priority queue to like store the values as we go through, and if we use a priority queue, then we could use the priority queue to always know the maximum element that we have as we are going, right? So as we let's say as we're going from left to right, we put the numbers into the priority queue, and then we pull or we take a peek at the elements. So that this is going to be like a mass heap. Like you're always the maximum element will be at the top, and you can pull the peek at the queue, right? Call peek on the queue, not pull it. You don't want to pull it to see if the the maximum element is uh, within the range, and if it is, um, then right, this you count that as a good array. Um, and if it's not, if it's not good, right, if you if if the number that you uh, is greater than the range, then you know that that number it really can't be in the array at all, right? So there's no contiguous subarray possible that includes that number. So what you would have to do is basically skip that number and then start over from the number after, right? So basically what I mean is um, you could have so you start at 2, so that's a good number. That's 1. So 2, 1, the maximum element is still 2, so that's good. When you reach 4, 4 is out of the range. So once that happens, right, you can no longer continue trying to grow the array. So you have to stop and basically skip 4 and continue on from 3, right? And then you keep doing that, right?
Yeah, the only thing is that I'm not sure how are we going to make sure that we consider all the possible subarrays in the priority queue.
Right. So all the possible stuff. So that's so how good question. So how do I skip? So how do I make sure that I consider all the possible subarrays, right? Because as I grow the array, um, hmm, okay. So let's think about this. So let's see if we could use a left. Hmm, could use maybe use a sliding window approach. Um, if we use a sliding window approach, then we could use maybe a right pointer index to grow the array, and as we increment the pointer, um, hmm,
Okay, so if you don't mind, let's try a different problem for now, and we can
sure,
come back to this problem later.
yeah.
Yeah, so let me give you a different problem. Yeah, we're just going to like explore the the weaknesses, what topics you need to like reiterate. So one of the topics is array. So this was one problem we just had. Is was an array problems. Now let's try this one.
Given n pairs of parentheses, write a function to generate all combinations of well-formed parentheses. Cool. Okay. Um, okay. So the goal is we want to get parentheses, right? We want to return a list of strings, and these strings have to be well-formed parentheses. Um,
Mm-hmm.
so, for example, when we have n equals 3, um, we return all combinations of all combinations of parentheses that have 3 pairs. 3 pairs. Yep. Okay. So I I think I've done a similar question to that. It's like the I think this cracking the coding interview question, right?
Okay.
Also DP. So the way that I'm thinking of doing this, so I've done a question that's similar to this. It's uh, like um, like number of paths. Like basically you have a 2D grid. I forgot what the problem is, and like you can't you couldn't go like you're on a 2D grid, right? And you have the option of going either down down or right, and you can't cross like the diagonal, right? And so that problem was basically equivalent to finding the number of parentheses in the number of possible pairs of parentheses for a given n, right? And this field is similar to this in the sense that we can use that approach also to generate the parentheses. So what I was thinking is um, you could have so n is 3, right? So
Okay.
um, you could have a 2D grid. Actually, it really I really miss the whiteboard. So much easier. So it has a 2D grid, right, which is uh, dimension of n plus one. And basically, the way that it would work is that it let you start at the upper right, upper upper left corner, and every time you go down, you add a parentheses. You add a left parentheses, and when you go to the right, you add a right parentheses. And basically, what you would have is what you could have is a bunch of strings or basically string builders containing the partially formed strings.
Mm-hmm.
At the end, at the bottom right, yeah, the bottom right corner, you're going to have the list of all strings that are
Yeah. Can you? Yeah. I see. Is there a way to do this in a recursive manner? Using-
recursive way.
Mhm.
Hmm, good question. So recursive way could be um,
Yeah.
let's
You can just say or like yeah, write some physical.
um, uh, recursively could be maybe let's see. Let me think about this. So I guess base case of the recursion could be when you reach n equals 0, return empty string. Yes, and when you have n equals 1, return a single pair. Um, and then what could also be done is so basically you have to consider all other possibilities, all other possible subarrays. So you could build
Yeah. So if you don't mind, let's try to have something a little bit simpler for on also a recursive. Let's say we have a binary tree.
mhm.
Maybe if you solve this one, help us to understand how to solve the previous one. Yeah, let's just pretend we have a binary tree like this. 4, 5, let's say 6, 7, and yeah, can we print it in this way? One, two, one, well, 1, 2, 4, 4, 5, 3, 6, 7. Basically, we return the function int tree that is given some tree node variable.
Oh yeah, so that you could do a def. Yeah, yeah, okay. So you could do a def first search on it, right? So
Mhm.
you could yeah, yeah, we could do that. Yeah, okay, cool. So So basically, yeah, like um, so okay, so I'm gonna write the way that you wrote here, right? So for three, you could do uh, so basically if tree equals null, return. Um, then you could do print tree. So this is this is pre-order traversal, right? So you could do something like system print line tree dot val
Okay.
and print tree tree dot left print tree dot right. Yeah.
Okay. And what if you want to change the order to something like that? 4, 2, 5, 1, 6, 3, 7.
So 4 4 2 5 4 2 5 1. So in order.
Mm-hmm.
So like switch the print line.
Mm-hmm.
So print go down the left subtree first, then visit this node, and then go down the right subtree.
Okay. Yeah, and what will change in the output if we change this one and paste it here? Can you write what will be the output?
That would be post order. Post
Mm-hmm.
order.
Yeah. And what will be the output?
So the output would be so you do print four. So it will be 4 5 um, 4 5 2 6 7 3 1.
Mm-hmm.
4 5 2 6 7 3 1. Yep.
Okay, that's looks good. Okay, let me go. Let's go to the next topic. Okay,
So
so
yeah,
theory.
we could use this, right, for in order to solve the parentheses in a recursive way. We could use recursion, right? It's like depth. It's like traversing a um depth first. Sorry, I can't pronounce that. Depth first search on the tree, and then you can go up to a given depth, right, where depth equals the number of pairs.
Mm-hmm. Yeah, we can do this. Yeah, you can if you want, you can do this. Yeah.
What's that? Sorry, I didn't hear what you said there.
Yeah. Can you hear me? Hello.
What's that? Yeah.
Yeah, I just said that. Yeah, if you want to do this, we can still do this. Yeah. Solve this parenthesis.
Oh, okay. Yeah, yeah. So um, okay. So I'm gonna do it here. Okay, so for parentheses, so what we're doing is basically we are um, recursing down a subtree, right? So um, hmm. so anytime we go to a left, go down a left node, that could signify we are uh, printing a left parentheses, right? Anytime we go to the right, we're printing a right parentheses.
Mm-hmm.
So would that work? So for
Yeah, I guess
example,
before we start coding, could you maybe like describing what is your approach?
yeah, okay. So we do. So let's have an example where you have a smaller subtree. So for example, let's just have 1, 2, 3, right? So basically, you start at 1, and then you go to 2, and before you go to 2, you print a uh, or you generate a left parentheses, right? And then once you're done with that, you come back from 2. 2 is a leaf node that has no children, so you're not gonna print anything. You go back to 1, and then go to 3, and when you go to the right, you generate as before you go into the right child, you generate a right parentheses. So the result of having this tree 1, 2, 3, it would be uh, this a single pair. Right? Um, if you have a bigger subtree, um, you go from 1 to 2, you generate a left parentheses, then 2 to 4, you generate a left. Right. Then 4 is a right it's a leaf node, so you go back to 2, go to the right,
Mm-hmm.
you generate a right. 5 is a
Mm-hmm.
leaf, so nothing else to do here.
Mm-hmm.
Then go back to 1, and then 3. Uh, 3 is a right,
Mm-hmm.
and then 6, and then you go back to 7. That's 7.
Mm-hmm.
Um, right. So that generates one possible pair. Hmm. So how are the other ones generated? Um, okay.
Yeah, I guess you can.
Well,
Yeah, you can just brackets, right? Like this. And this one is going to be just empty, I guess. Right. So basically, yeah. So you'll be able to generate brackets. Yeah. So it just really depends. You also have one more input parameter is n. It's a number of
hmm
uh, pairs of brackets basically,
hmm
and you just need to guess. It's not exactly kind of like a tree traversal. It's just rather the similarity between these two problems is that both of them are using like recursive way of traversing, but the you are traversing in the first problem you're actually traversing some a fixed kind of tree that is like also given. But here by traversing you actually you pick either you kind of attached a left bracket or a right bracket, and at all the levels of traversal until you reach the length of the string equals to length of the string equals to this multiplied by 2 basically characters. You have n number of pairs of brackets, right?
Right. Okay, so you basically start at the root, and then you continue every time you go down into one of the subtrees, left or right, you append either a left or right bracket.
Exactly.
Sorry, Grace, and as you do that, so your the stop condition will be when the length of the string is n times 2, right? N times
exactly.
2.
Yeah. So your tree continue to grow like depending on the n, basically.
Right. The concern I have is, like, let's say if you're like going all the way to the left, right? For example, if you just keep adding left parentheses and then you have n times 2 on left bracket, right? How do you so how to check if the string that you're appending if it's good?
Yeah, that's a good question. You need to do you will end up with, let's say if your n equals to 3, right? You eventually will end up with having something like that, right? So which is invalid. So you need to do some type of validation, I guess.
Yeah, okay. So you could just that's fine. That's what I was thinking too. Like, keep track of if how many left and right parentheses you have. You just got to make sure that they're the same. You only like add this. You only save this if it's actually it has the correct number of each.
Yeah. So there are a few ways of doing this. One way is you're gonna collect the string. We check if it's valid or not. Another way is you're actually going to kind of stop collecting open brackets until you reach like this point, right? It's basically a more optimal way of doing this. Once you reach this, once you're picking a bracket for position, what is the position? 0, 1, 2, 3, right? Position 3, you know that you already have like all the brackets that you collect before, they all are open. So pretty much it means that now you cannot collect more open brackets. You can only collect closed brackets. So so this is another way of doing this, which is more optimal. So before we jump into this, I would suggest you to do it as a homework. Maybe you can explore one more topic. Just
yeah. Okay.
Yeah, let's do this. Yeah. So let's just pretend we have 1, 2, 3, 4, 4, and this is the kind of sorted array. And we have a target. Let's say it's element 4, and we want to return the rightmost index of this target. This. Otherwise, just return -1. How would you do this?
So we have an array with is the array sorted?
Yeah, it's sorted.
It's sorted, and we have a target, and what we want is look for the target, and find the rightmost index of this target if it exists. Otherwise, return return -1. Oh, okay. So I think we could do binary search on this, right? So we have the target, the array is sorted. We're looking for a specific target. We could use binary search in order to find the rightmost. So this is I actually kind of was studying this the other day, right? So for this binary search, it's not enough to just look for a specific value, right? We're not looking for 4. We're looking for the rightmost target. So you actually need what we actually need to do is look at as you're going through doing binary search on the target, you're looking at your the middle element and the one to the right, right? And then you gotta figure out whether if you found the target, if it's 4, right? Whether it's you check whether it's the last one, either when you reach the end of the array, when mid equals high, or the the number to the immediate right is a different number, right? So the approach is, will you be okay with me like coding this up?
Yeah, sure.
Okay, cool. So sorry. Okay, so cool. All right, so we want the rightmost index of this target if it exists. Otherwise, return. Oh, thank you. Sorry about that. Otherwise, return -1. Okay, so int. So int find rightmost index. Okay, so we have int nums int target. Okay, and then the idea is return -1. Not found. Okay, we're gonna have our low and high. So left index equals 0, and right index equals -1. And while left index less than right index, int mid equals index plus right index over 2, and then what we gotta do is if nums mid equals so we found mid is target. So in that case, we have a couple of things that we need to check. We need to check if we are in the end of the array. So if mid equals nums left -1, simply return mid, because by definition this would be the rightmost element. Okay, so if we're not at the end of the array, okay, nums mid. Then we can check the rightmost element. The nums mid plus 1 equals not equal target. Okay, so that's the other condition where that would mean this is the rightmost element. So if it's not, then that means it's not the rightmost element. So
Okay.
if it's not the rightmost, so if it's not the rightmost one target, then or we need to go towards the right. So else left index equals mid. Else if okay, so that's when the condition when we actually found target. So now if we didn't find target, then we do the regular binary search. We go left or right. So if nums mid less than target, okay. So if nums mid is less than target, we need to go to the right. Else right index equals mid.
Mm-hmm.
Okay, so now let's see. Do I got this right? Let's see. Gotta make sure this this right left index is less the right index. So let's do let's debug this. Let's walk through this code. So target is 4. So and then we have how big is this thing? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 elements. And prime equals 17. Okay, so we have left index equals 0, right index equals 15.
Yeah, so yeah, sorry for interruptions. Yeah, so I think it actually works. So I just wanted to point out one edge case, like if, for example, if we have, will it work if we have only one element?
Sorry. So if we have, so yeah, so that's if we have this would not work, right? So this, I think this is equal, less than or equal.
Yeah, we generally use equal, less than and equals here. Yeah.
Yeah.
Yeah. Now I think it will work. I believe. Yeah. So you have, yeah, compare with the last one. Yeah. If it is, yeah, if it is the last one and equals to target, then that's pretty much it. You return. Otherwise, you check if it is. I see if it's still equals to target, but the next one doesn't equal to target. Yeah, which also means that we found the target. Yeah. Otherwise, we just go to the right. Okay. Yeah, this looks looks correct. Okay. Yeah, so basically we run out of time. Let me just go through some feedback. So the first problem is something that I ask in a real interview. Usually it's a position as a senior software engineer. That's why it's a question. The question is pretty. The problem is pretty challenging.
Mm-hmm.
So I would recommend you to practice solving this problems. Start with. Let me just give you to that. Oh yeah, so this one. Try to solve these few problems. One is the two sum, then three sum and four sum. They all similar problems.
Mm-hmm.
Yeah, so basically, and just in your free time, I guess you need to practice solving more problems on arrays.
Mm-hmm.
Arrays, and well, this particular problem is pretty challenging. It have multiple ways of solving it, and apart from n squared, it also has linear solution.
Mm-hmm.
Yeah, so just do it as your homework. Now, then the second thing we're trying to solve problem on recursion plus backtracking. So
Mm-hmm.
yeah, so try to practice this topic. I would recommend you to solve. Where is that? Oh yeah, this problem. Yes, it's also a similar problem. It's a GFS plus backtracking. It's one problem, and also another interesting problem that I would recommend you to solve is actually a couple more other problems that frequently asked on the real interview. This one and second. Once try to solve them. Also try to like code the 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 solution that we were discussing. Let me actually copy it. Copy it. So I'm going to copy it here. Okay.
Mm-hmm. Oh, cool.
Yeah. So solve this after I finish with the parentheses. Then solve these three problems. Now recursion plus binary is looks like this topic you know pretty well. I think you can just like uh, just practice some medium level problems on lead code on binary tree topic.
Mm-hmm.
Yeah, so it's also pretty frequently asked on the interview, in the real interview, especially at Google. Well, not just at Google, but all the other companies as well. Yeah, so then, so for binary search, I think, I think it's pretty good. For practice, I would also recommend you to solve a very famous problem. So very frequently asked, it's a find element in a rotated sorted array.
Mm-hmm.
I'm sure if you heard of this.
Yeah, yeah.
Yeah. So, and then the second thing is you can practice solving the same thing, but for with duplicates, there's a second version of it. Yeah. So we have not, apart from this, I would also recommend you to we like did not talk about any like graph theory problems. Theory. Yes, if you're talking about if you when do you have a phone screen, by the way?
It's next week.
Next week, okay. Yeah, so graph theory, I think that's I would bet that graph theory is something that most frequently asked at Google. They ask a lot of graph problems. Yeah, so definitely.
Yeah. So breadth first search, depth first search. Yeah.
Yeah, they usually, they ask kind of. Generally, the problems that they give is a combination of multiple other problems. For example, if I try to practice this too. So this first one is problem is also includes some DP,
Mm-hmm.
combination of graph theory plus DP. Of plus DP, and this one robot room cleaner is also it's like graph theory plus some backtracking.
Mm-hmm.
Interesting problems actually. Yeah. So also we did not talk about topological sort topic at all. It's also very frequently asked topological sort. Now topological sort it is. I have a problem. Oh yeah, this one. It's a course scheduling. It's also a very famous problem. So practice and learn how to do this topological sort, like how to detect cycles in a directed graph.
Mm-hmm.
Yeah, so it's part of this topological sort. So like learn how to do this. Those like topics are related basically. Yeah, because topological sort basically. Have you heard of topological sort?
Yeah, yeah. It's like it's it's not. So I'm guessing it's like a way to like I guess you can use it to sort numbers or like arrange nodes in a directed graph.
Yeah, something like that. Basically, let's say it's your a typical like problem you have some a dependency graph.
Mm-hmm.
Yeah, and you need to like, for example, dependency graph. You need to like print out the way how you're going to traverse this graph.
Oh yeah, like
Dependency. For example, when you if you compile from some project, right, you have some dependencies there.
Mm-hmm.
Like you have one, let's say your project may require one library, and this library might depend on another library,
Mm-hmm.
right? And it means that, for example, you have a project, right? Project, let's say it depends on library A, and then library A itself depends on library B.
Mm-hmm.
So what means that you need to first you need to build library B, because pretty much everyone depends on it, right?
Mm-hmm.
And then you build A, and then only then you start like building the project, So this is like problems this topological sort solves. So this is important. And on the other hand, it can be scenario that project depends on library A depends on B, B depends on C,
Mm-hmm.
and C depends on A again, right? So it means that to build A, we need to build B, but to build B, we need to build C, but to build C, we need to again build A. So it's like there's a cycle here.
Mm-hmm.
Cycle means like it's a basically error. Error means that we cannot
Mm-hmm.
to like build this project basically because we have this cycle dependencies. The only problem here is that how we're going to detect the cycle. There's an algorithm that is used to detect the cycle basically. So this topological sort and cycles detections related topics basically. Yeah, so just practice this. Yeah, I think that this would be it from me, I guess, since you have one week left, probably also top 100 Google problems from LeetCode is also
Mm-hmm.
so it's worth like practicing those as well.
Okay. Thank you. Yeah.
Yeah. Any questions?
Yeah. Do you have like anything like feedback like in terms of like I guess communication besides anything to improve on?
Yeah, in terms of I guess like I would say that they probably, let me see. Yeah, for the first, I think that yeah. So for the first problem, I think that let me see. Yeah, I think that the most important thing is probably problem solving.
Mm-hmm.
Yeah, so you know that there are three categories how we like evaluate here. It's like one is technical skill. Second thing is problem solving. Third one is communication. Yeah, so I would say that your communication is pretty good. I think you are pretty openly, communicate. As long as you know how to solve it, you openly communicate and pretty efficiently, But if you don't know how to solve, of course, your communication is going to also be like not like efficient because like there's nothing to communicate, right? If you don't know how to solve. So what is technical skill here? technical skill generally. If you know how all this, how to by binary search, for example, how to do some tree traversal, how to do topological sort, GP, those technical like kind of data, algorithms, fundamental algorithms and data structures, right?
Mm-hmm.
And problem solving is when you have the kind of some ability to apply this data structures and this fundamental algorithm, and maybe sometimes combine them to solve problem, right? So I would say that I guess like you would, if I were you, I'm not sure if you have a chance to postpone with this phone screen. I'm not sure if it's already like strong, like if it's already scheduled, and if you cannot like postpone it. But I would recommend you maybe practice a little bit more. This would be my recommendation, to practice a little bit more, because array problems they are pretty frequently asked. So as well as like graph theory, we have not practiced on graph theory, but all the graph theories, not all, but lots of them, they use a recursive, and they are somehow like related to backtracking, which was this parenthesis problem. It was on backtracking, which is my expectation would be that a candidate would be able to solve it in 2 minutes, just off the top of their head, basically, because it should be like, if a candidate is strong, it's pretty much a very fundamental problem for the recursive and backtracking, basically. And so I'm not sure what also level what you're interviewing for at Google. Do you know your level?
Yeah, like L3, new graphic. Yeah.
Yeah, I heard from one friend of mine who conducts interview with for like internship. He says that it's actually that he finds interviews for internship is harder than for other positions, because interns, they don't have much experience yet, and the only thing they can show off is their like problem solving skill, and their technical skill.
Mm-hmm.
This is what he told me. This friend of mine. So I don't know how like true it is, but I guess it's kind of, there's some kind of makes sense to me. So I think that but just generally, I think what I just yes, I think that this is the script that I usually recommend. I'm going to paste it below. So this is the kind of script I usually recommend to use when you solve a problem in the interview.
Mm-hmm.
So I pasted in line 187. So you kind of like you try to understand. For the first problem that I asked you is that I think that I had to like intervene to help you with understanding the problem. Maybe it was kind of okay to me, but I think that maybe generally my expectation that the candidate would be able to kind of come up with this n-square solution by himself, because it's a suboptimal solution and should be pretty like straightforward. So and you were able to come up with the brute force, which is good. And I think that maybe what you could definitely improve is that when you walking through the approach, you like tend to maybe it's only my perception, but I have a feeling that you tend to kind of jump straight to coding before you walk through the approach, walk the interviewer through the approach, and like understand this approach and get like confident that this is indeed works and has good time complexity.
Yeah.
And yeah, so this is maybe one thing that you can definitely work on. But as I said before, apart from that, I would recommend you to maybe practice a little bit more. Just like when did you start like your preparation?
Like a couple of months ago. Yeah.
Mm.
I haven't. Most of the times, just like doing going through like the algorithms test book and leak code, but I haven't done a lot. I haven't done a lot of like the like this, right, the mock interviews. I think it's kind of different because sometimes like once I'm actually someone's on the other side, like my mind kind of goes blank sometimes, so it's like that's kind of annoying, but that's I need to practice. I think I need to practice more and be more comfortable, like doing these interviews, the mock interviews.
Mm-hmm.
And,
Yeah, I don't know what is your way of practicing. Generally, it's recommended, and this is what I did myself. I practiced like every day 2 hours
okay.
for a few months. Also participate in different types of like contests, uh, and this is like what really helped me.
Oh, thank you. I'm gonna try contests like those are because those are timed, right? Like you have the pressure and stuff.
Yeah,
Uh,
yeah, and this is what I also recommend you to do.
Thank you.
Yeah, I'm not sure if it answers your like question in terms of.
What's that?
I'm not sure if it answers your question. Like your initial question was what I could
Y-
recommend you
Yeah,
studying.
thank you so much. Yeah. Yeah, this is great. Thank you. It's a lot of details, and all of this is really helpful. I think this is good. Thank you so much.
Yeah, yeah. Do you have any more questions?
No, I think I'm good. It's just practice. I know like this. I need to practice all this, and I want to go over that question. I'm gonna think about it. The first one, the
Mm.
uh, yeah, because that was an interesting question. I know there's better solutions. I'm gonna try to think about that and try to come up with a solution for homework.
Yeah, yeah. Try to finish the N square approach that you worked on. You started working on. You started thinking on, and then then try to think how we can improve, how it can be improved to a linear solution. Yeah.
Thank. Would it be okay to just like copy and paste these the stuff you wrote on my notepad?
I think that you will have access to this. Sure, you don't have to do this. I think
Oh,
after we finish the interview, you will have access to this, to this, like all the notes.
oh, okay, okay, cool.
Yeah, so don't need to worry about it. Also, yeah, so I'm gonna share my contact with you as well, so you can ask me if you have any additional question. You can ask me as well.
Oh, thank you very much. Really appreciate it.
Yeah.
Thank you.
All right. Yeah, that's pretty much it for me.
Thank you. Like honestly, this is thank you. Very helpful, and thank you for taking the time to give me all these good advice. Thank you so much. Really appreciate it.
Thank you. Yeah, and have a good day and good luck on your interview.
Thank you. Thank you. Have a good
Yeah.
day.
Thank you.
Bye.
Bye.